Hello, welcome to my presentation on the Swigart research I did over the summer. I worked with Dr. Reich on analyzing the effects of disorder induced onto the exciton spectrum. Today I'll be talking about how the disorder causes changes in the broadening and also how it causes changes in the shifts of the exciton ground and excited states. So to start with, we assumed that the disorder potential only acted on the exciton as a single entity. So we, instead of looking at the individual effects on the electron and the positron in the exciton, we looked at the center of mass of the exciton and found the broadening term induced by disorder on the exciton from that center of mass coordinate. We found the energies and exciton widths for the ground states and the 2s and 2p states, mainly the 2s and 2p states, to see if there was any broadening that exceeded the binding energy of the exciton, which would destroy the exciton. It was found that the broadening was less than the binding energy, and that also the 2s and 2p state by broadening terms were the same, but the shifts in energy of the 2s and 2p states were different. So in figure A, you can see the broadening of 2s and 2p, that they don't exceed the energy, the binding energy of the excited states. But in a figure B, which is a closer up look of the disorder potential, as you can see the randomness in the potential curve, you can actually see that the shifts between the 2s and 2p states are different. This means that there's splitting of the 2s and 2p states in the exciton naturally from the disorder acting on the exciton. And this effect has not been seen optically before without the use of an electric field, which means that there is fundamental splitting of the 2s and 2p states when a defect or an impurity is present in your material. This is also very reminiscent of the Lamb shift. And it is not the exact same as the Lamb shift, but the similarities were noted. In summary, we've shown that the disorder broadens both the exciton ground state and the excited states. It also causes shift in the excited states of the exciton. And this shift causes splitting of the energy levels that previously could not be seen optically without the use of an electric field. And this is similar to the groundbreaking Lamb shift. Thank you all for watching my presentation. I hope this gave some insight into the kind of research I do with Reich. I hope everyone has a nice day.